Okay, so this is my video for standard 1.1. I chose problem 1.6, which gives us this arbitrary quantum state vector written in the x basis. And then they want us in part A to find the probability of this system either being in the z up spin state or the z down spin state or the x up spin state or the x down spin state. So let's start by seeing what the probability of finding the system in the z up spin state is. So to do that, we want to find the modulus squared of the inner product of our state vector taken with the z plus basis vector. So essentially what this is asking is how much of our quantum state vector psi is the plus z vector. So we just start doing this out, but then all of a sudden right away we are stuck with a problem because we don't know how to multiply our z plus basis vector with our x plus basis vector. Luckily, we know how to write our x plus basis vector in terms of our sz basis, and the same for the x minus vector. So we plug those in and get something that looks like this. And then we can just go ahead and multiply the pluses with the pluses to get 1, the plus with the minus to get 0. That leaves us with this. So then we just take the modulus squared of that complex number in there, and then we end up with the probability of it being in the up z state is 1/2. So when we calculate the probability of the minus z state, we'd better get 1/2 as well, because we need both of these. It has to be either in the plus or minus state because there's only 2 of them, so they better add up to 1. So let's see if that is the case. So same thing for the minus z state. We multiply our state vector with the minus z basis vector and take the modulus squared. We run into the same problem, so we do the same substitution as we did before. Now the multiplication is all nice and pretty, and we do it out, and we end up with 1/2. So we can be pretty confident that we did at least this calculation right. So let's check the probabilities of it being in the up and down x spin states. So this is much nicer because we don't need to do that substitution that we did before, so we can just use the... So essentially all we're doing now is projecting our state vector onto the plus x basis vector, and we do that just by taking the inner product of the two. So when we do that, we end up with 4/13. Then we do the same process again for the, and we're gonna hope we'll get 9/13 when we do the minus x1. We do the same process. We end up with 9/13, and they add up to 1, so we can be fairly confident that we've managed to do this calculation correctly. Finally, they want us to draw some little histograms to show the probabilities of each state respectively. And there that is. So that's about it for standard 1.1.